Hi everyone. We're gonna try doing the lectures real quick in this different setup, and today we're combining two lectures in one, so I'm going to be going through topics a little quickly, but we can talk about it in class if you guys want. Okay, so remember where we are with population models. It's been a little while since we've looked at them. So if we look at just one species, we can see that the population growth rate is equal to the per capita growth rate times population size as a function multiplied by the proportion of the population that's at carrying capacity. So how close the population is to carrying capacity. So that's our density dependent population growth model. So if we're now in competition models starting to add multiple species, what we're looking at here is species 1 has this population growth model. Species 2 has, a similar density-dependent population growth model, except we're just changing all of these subscripts to 2. So we need to add in competition. And remember, competition is a species interaction where when they come together, both species have negative outcomes. So it's considered an antagonistic species interaction. All right, so let's go ahead and add in that negativity. So what we would do for species 1 model is we would say this population growth rate of species 1 minus, this is an alpha. I'm not great at drawing alphas. Minus alpha times N2 divided by. Okay, so what that's going to give us is the negative effect of competition from species 2 on the population growth of species 1. So remember, these are negative species interactions, and so it's always going to be negative. You're not going to have this change to a positive. Okay, so when alpha is equal to 1, that means that intra is equal to inter-specific. Competition. So what happens there is that any one individual that is added from species 2 is equivalent to just adding another individual of species 1. However, if alpha is greater than 1, inter specific competition is more intense than intra. And of course, that means if alpha is less than 1, intra more intense than inter. Specific competition. Okay, so now let's think about what happens to species 2 if we add competition from species 1. Now we're just going to have a beta instead of an alpha. We're going to say N1 instead of N2. And we're going to look at K1 instead of K2. So the same basic kind of equation here, but and it has the same rules in terms of if you have beta equal to 1, that means that adding one more species, one individual, is equivalent to adding another species, two individual. So inter and intra-specific competition are the same. If it's more than one, that inter is more important or more intense than intra, and if it's less than one, intra-specific competition is more important or more intense than inter-specific competition. And it's important to note that even though those same rules apply to both alpha and beta, that doesn't mean that alpha and beta are equivalent values. So think about that for a minute and think about why you might see alpha being either lower or higher than beta. Okay, so what I hope you thought of is that, species have different competitive abilities. And so it's very likely that species 1 is a better competitor than species 2. And that would make the beta higher than the alpha. Now, in a face-to-face class, I would then have you guys run through the Lotka-Volterra models in Populus. What I'm going to do instead is I'm going to post a different video with the Lotka-Volterra models in Populus and move on to the next topic here.